Hello everyone, this is Xinyi. In this presentation, I will introduce our paper, From Query to Explanation, Uni-RAG for Multimodal Retrieval-Augmented Learning in STEM. This work is conducted with Yan Hao, Louis, Shuai, Professor Feng Guangqiang, and Professor Eric Cambrier. The main question we ask in this paper is very simple. How can we help students and teachers retrieve useful STEM learning materials from different kinds of queries, and then turn those retrieved materials into clear educational explanations? Let me start with the motivation. In real STEM learning, students and teachers do not always ask questions in clean text. They may use a photo, a sketch, a low-resolution image, a diagram, or even an audio description. For example, a student may ask, why does a pencil look bent when placed in a glass of water? A traditional retrieval system may return several images of a pencil or a glass, but it may not explain the physics behind the phenomenon. In education, that is not enough. Students need not only relevant materials, but also clear explanations. In that example, they need not to understand that the phenomenon is caused by refraction, where light burns when passing from air into water. So the goal of this paper is to move from query to explanation. We want to retrieve useful STEM materials from diverse query styles, and then generate a grounded educational explanation. To achieve this goal, we propose Uni-RAG, a multimodal retrieval-augmented generation framework for STEM education. This framework builds upon our previous paper, published in ACL 2025 on Uni-Retrieval, and further extends it from multi-style STEM retrieval to retrieval-augmented educational explanation generation. The framework of our Uni-RAG has two main parts. The first part is Uni-Retrieval. It supports different query styles, including text, natural images, sketches, low-resolution images, and audio descriptions. The query is first mapped into a shared representation space through prototype learning, and then Uni-RAG uses a prompt bank with a mixture of experts and LoRa. The prompt bank stores style-aware prompt tokens. Giving a query, the system retrieves the most relevant prompts and adapts them through lightweight experts. This helps the model understand different styles, such as diagrams, sketches, handwritten notes, or natural images. And the second part is the RAG module. After retrieving the top K relevant educational materials, Uni-RAG sends the retrieved evidence, the system prompt, and the original query to an instructional turned language model, CRIN 3. The final output is not just a list of retrieved items. It is a human-readable educational response, such as an explanation, a feedback, or instructional content. This design is also efficient. Most of the backbone model is frozen, and only the prompt bank-related components are updated. And therefore, Uni-RAG can adapt to different educational query styles without full parameter fine-tuning. And for the experiment part, we evaluate Uni-RAG on the SER dataset, which is our primary benchmark for STEM education retrieval. The SER dataset was introduced in our previous ACL 2025 work, Uni-Retrieval, as a STEM-oriented multi-style retrieval benchmark. And in this paper, Uni-RAG, we use SER as a primary benchmark and extend the retrieval setting toward retrieval-augmented educational explanation and generation. As for the results, we compared Uni-RAG with pre-trained cross models, large multimodals, style retrieval models, prompt learning models, and database roving retrieval models. Across all 5 major retrieval scenarios, Uni-RAG achieves the best performance. Specifically, it reaches 84.1 RH1 for text-to-image retrieval, 85.1 RH1 for sketch-to-image retrieval, 77.2 RH1 for R2-image retrieval, 89.5 RH1 for low-resolution to image retrieval, and 53.7 RH1 for audio to image retrieval. This shows that Uni-RAG can effectively handle diverse query styles in STEM learning context. And second, we evaluate whether better retrieval also improves generation quality. The first table reports the generation quality evaluation over a 500 sample evaluation speed. Compared with closed-book Qwen 3 and vanilla clip-based RAG, Uni-RAG achieves higher scores in faithfulness, grounding, usefulness, and pedagogical quality. More importantly, the hallucination rate is reduced to 8.2%, compared with 20.2% for vanilla RAG and 39% for closed-book Qwen 3. And the next table further shows that educators give Uni-RAG the highest overall satisfaction score, 4.38 out of 5. Also, our paper provides case studies across science, technology, engineering, and mathematics. The case study further shows how Uni-RAG supports different STEM domains. In science, it can explain a chemistry experiment and provide safety cautions. In technology, it can explain the working principle of a line-following robot and provide calibration suggestions. In engineering, it can explain the mechanical principle of a crane. In mathematics, it can explain the derivative through a tangent line diagram. Those examples show that Uni-RAG can connect diverse inputs with domain-specific educational explanations. To conclude, I would like to summarize 3 takeaways. First, STEM learning queries are naturally multimodal and style diverse. For a useful educational retrieval system should support not only text, but also images, sketches, diagrams, low-resolution inputs, and audio descriptions. And second, the prompt bag with mixture of experts and LoRa provides an efficient way to adapt to different query styles. It improves retrieval performance without full parameter fine-tuning. And third, better retrieval leads to better generation. By grounding the language model in retrieval educational evidence, Uni-RAG improves faithfulness, usefulness, and pedagogical quality, and user satisfaction. But also there are limitations. The current generator mainly produces textual explanations, although Uni-RAG already retrieves multimodal evidence. In future work, we can extend the system with a full multimodal generator that produces annotated diagrams or curriculum-aligned visual explanations. Overall, Uni-RAG provides a scalable and pedagogically grounded framework for intelligent STEM learning assistant. And that's all on my presentation. Thank you for watching for this Labcast.